Hi everyone, welcome to my channel, where I explore the fascinating world of machine learning and artificial intelligence. Today we're diving into an exciting project, human face detection using YOLOv11. In this video, I'll guide you step by step through the process of building a face detection system using a pre-trained YOLO model. Whether you're new to computer vision or looking to enhance your existing projects, this video has something for you. So, grab a notebook and let's get started. First, we need a dataset to train our model. So, let's download a face detection dataset from Kaggle. The link is provided in the description. Click on the download button, and you'll get this code to directly download the dataset in Colab. Alternatively, you can also download the zip file if you prefer. Now, let's wait for the dataset to be downloaded. So, our dataset is downloaded. Let's take a look at how it's stored. This code lists all the files and folders in the dataset directory. As you can see, we have three main folders: labels, labels 2, and images. Let's see what's inside the labels folder. Now, let's check the train folder inside labels. These are the label files that will be used for training our model. Let's take a look at the format of the labels used in YOLOv11. Here's a sample label file. Each line contains the following information. The first value is the class ID, followed by the coordinates of the bounding box in the format x-center, y-center, width, and height. These values are normalized to the image size. To train our model, we need to create a YAML configuration file. In this file, we specify the paths to our dataset, including the paths for training and validation images and labels. We also define the class name. Since we only have one class, human face, we list it here. This configuration will guide the model during training. Now, let's save the configuration to a YAML file using Python. This code will create a config file .yaml and write the dataset paths and class names into it, so it's ready to be used for training our model. Now, let's load the YAML configuration file we just created. This code reads the config file .yaml and loads its contents, making it ready to be used in our model training. Let's take a look at the contents of our YAML file to verify that everything is loaded correctly. Next, let's install the Ultralytics package, which is required for training our YOLOv11 model. You can do this using the command pip install Ultralytics. Now that we have installed the Ultralytics package, let's import the YOLOv11 model from it. This will allow us to use YOLOv11 for our face detection task. For our project, we'll use a pre-trained model. In YOLOv11, we don't need to create a model from scratch like we do in TensorFlow or PyTorch. Instead, we can simply load a pre-trained model like YOLOv11n.pt and fine-tune it on our dataset. Now, let's take a look at how to use YOLOv11 on the Ultralytics website. For detection, you can choose from models. For our project, we'll use the YOLOv11n model. This is an example code showing how we can train a YOLOv11 model. Let's train our model. This code trains our YOLOv11 model using the dataset specified in the config file .yaml for one epoch. I use one epoch here because training can take a long time, but I've already trained the model for 10 epochs. For better results, I recommend training the model for 10 or more epochs. And one thing, don't forget to change the runtime to GPU, as it takes a long time to train without it. Now that we've changed the runtime to GPU, we need to rerun our entire code. You can use Ctrl plus F9 for Windows or Command plus F9 for Mac to reset and rerun all cells. Now, we realized a small mistake in the config file. In the names field, we need to use brackets to specify the class name as a list. Now that we've fixed the config file, let's train the model again. This is where our trained model is saved. We'll load it using the following code and use it to test our model. This is where our trained model is saved. This code runs the inference on the test image and saves the results. You can also test on a video by providing the video path and use the save equals true method to save the output with detections. The output is saved at this location. Let's view it now. Let's test the model on another image. I tested the model on a video, and this is the output.